Good morning, and once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to just focus on example 5 of handling data 7, which is actually the tail end of the probability as a topic. And we are being told that a vet has a 90% probability of finding a particular virus in a horse. Finding a particular virus in a horse is not automatic. It has its own probability, which is 90%. If the virus is found, the operations has an 80% success rate the first time that it is attempted. That means in case we identify the virus, we have 80% success rate in the first attempt of the treating the horse. If this operation is unsuccessful, it can be repeated, but with a success rate of only 40%. That means if the horse does not get cured in the first attempt of treatment, we can attempt again, but this time with only 40% probability of the horse being healed. Any operations after that has such a low chance of success that a vet will not attempt further operations. That means there is no horse that can be operated 3 times, because from the 3rd time onwards, the success rate is very, very slim. Now, let's look at the question. What is the question? The questions are, what is the probability that a horse with the virus will be cured on successively once? That is question number 1, which is not captured in this literature. What is the probability that a horse with the virus will be operated on successively once? First of all, we have to note that even detecting the virus is still a chance. So let's kind of have a tree diagram that will illustrate this information. So we have probability of we can detect the virus or we can fail to detect the virus. The moment we detect the virus, we can operate the horse successively, or we can operate the horse with no success. See? Let us first of all beef up that. The probability of detecting a virus is 90%, which is 0.9. The probability of not detecting a virus is therefore 10%. This one has to be 1 or 0.1. If the virus is detected, the probability of operating the horse successively is 80%. That means 0.8. The probability of operating the horse without success is, of course, 20%, which is 0.2. If we are not successful in the first attempt, it means we have another chance of operating the horse. This time we can be successful and we can also fail. If we fail to cure the horse in the first attempt, we can try it again, but with a success rate of 40%. So the rate or the probability of succeeding the second time, 0.4. The rate of not succeeding is now bigger, 0.6. And we are told now there is no need of operating the horse beyond the second operation, because the success rate is very, very slim. Now, first question. What is the probability that a horse with a virus will be operated on successively once? First of all, part A, the probability that a horse will be operated on ones. First of all, we have to detect the virus and operate that successively. And we just have this route. You can see this route. We have to detect the virus because detecting the virus is not obvious. We have to detect the virus and operate successively. So where are we now? The probability of successively detecting the virus is 0.9 and operating it successively 0.8. And if you look at that, this is now 0.9 times 0.8 and you get 0.72. This is 0.72. That is the answer to part A of the question. Part B of the question is asking, what is the probability that a horse with the virus will be operated successively on by the second operation? The second operation. What is the probability that the horse with the virus will be operated successively on by the second operation? First of all, again, we have to detect the virus and we have to fail the first time. That means we have to detect, fail to operate successively, and then succeed the third time. And as you can see, there is this route. Which means what? This is detection of the virus 0.9 and operate unsuccessfully 0.2 this time round, and then operate the second time successively 0.4. We have to have now 0.9 times 0.2 times 0.4, which is now 0.072. We have to have 0.9 times 0.2, detect the virus, fail the first time, and succeed the second time, which is 0.072. 0.072. And that is now the answer to part B of the question. What about part C of the question? The question is asking, what is the probability that an infected horse is cured? Infected horse is cured. We don't care whether it is going to be cured after the first operation or after the second operation. It can be cured by the first operation, which has to follow this route. It is detection and success, detection and success, or we can follow this route of detection, failing the first time and succeeding the second time. In other words, we have this route which is ds and this route which is ds prime s, and the word between them is or. In other words, we have now 0.72, which is this, plus 0.072, which is the other one, plus 0. And we get what? 0.792. So this is 0.792. This is now the probability that an infected horse is cured, either by the first attempt or by the second attempt. But in both cases, the virus has to be detected. That is how we can easily solve that question. Remember, the questions were not there. I hope they're in the slides, but it is okay. Just follow them and see what we have done. Thank you so much. Let us meet in the next video.